Yes, as it was introduced, I would like to speak about data sharing, and I would like to first start with a video, and that video is a little bit discouraging, that they disregarded everything, or this guy disregarded everything that is needed for sharing the data. And research data are really important. They are generated in the course of scientific projects through digitization, search research, experiments, measurements, surveys, or interviews. And it is the basis of scientific knowledge in almost all fields of science. But what is important is that very often there is a huge potential for investigating a wide range of research questions that were not always foreseeable at the time of data collection. And therefore, data sharing means that you provide the data for other research purposes and sometimes also to widen the study base. And that means it is an efficient use of resources. Now, the requirements started already as early as 2007 to share the data, and it was the OECD that called for easy access to research data for the entire scientific community. In 2016, the FAIR Guiding Principles for Scientific Data Management and Stewardship have been published, where FAIR stands for findability, for findable, accessible, interoperable, and reusable of data. That has been taken up, at least in Germany, but I also assume in the US and other European countries, that has been taken up by funding institutions and research organizations, and they ask now that the data should be as open as possible and as closed as necessary. In Germany, in 2016, the German Council for reusing such data established or asked to establish a national research data infrastructure. And in November 26, 2018, the federal government and the federal states of Germany agreed on funding the so-called National Research Data Infrastructure, the NFDI. It is a nationwide distributed and growing network, and the aims are to systematically develop a scientific data pool, to sustainably store the data and also to improve the access to the data, and to start an international networking. The budget was foreseen to be 90 million euro per year in the final stage of funding. And it started in 2019 with an initial call for consortia, and 3 rounds were performed in total. And now 26 domain-specific consortia and 1 network of consortia are funded. In October 2020, the nonprofit association NFDI was established to coordinate all overall activities. And here you can see all consortia at a glance, and they can be allocated to the social sciences, to the life sciences, where you can find my consortium, that is the NFDI for Health, the natural sciences, and the engineering. And then you have this overall, this network of consortia called BASE for NFDI. Now, the National Research Data Infrastructure for Personal Health Data, the NFDI for Health, was lucky. That means we got already funded during the first round of applications. That means our funding started in October 2020. That means at the peak of the corona epidemic, and that was really an endeavor and a challenge for us. And it will last until September 2025. We just applied for the second funding phase. And the overall budget is about 15 million euro. Juliane Fluck and myself, we are as a spokesperson. And here you can see that the data bodies that are included are spread all over Germany. And it consists of epidemiological and public health studies with 26 local studies with more than 400,000 participants. And of course, the German national cohort that is well known to BERT with more than 200,000 participants. And then we have also the clinical trials, where 27 university study centers, denoted as the green dot here, are involved. And then we have also some registry, primarily cancer registries, that are involved, and also administrative health databases. Now, what are the obstacles for data sharing? I mean, you have seen some of the obstacles in the video. There's a problem that you need resources for data management. That means for data cleaning and for curation of the data set. Then you have to provide the data to a repository, or you have to maintain your own repository. And you have to prepare metadata that describes the data set pretty well. And then very often data standards are missing. That means you need quality criteria for your data that you offer to others. That means you have to also, for instance, describe the data provenance. And also the structure of the metadata should be harmonized, and that is not still the case. And then there are many privacy concerns. This relates to data protection, since you are sharing individual health data. And also the problem is with respect to the re-identifiability of individuals. And then there's a major ethical concern, because the approval for data use is based on informed consent. And in particular, in former times, the participants were not asked whether they allow that their data are shared for other purposes. Now, the NFDI for Health has a mission to increase the value of research in epidemiology, public health, and clinical trial-based medicine by making high-quality data international findable and accessible according to the FAIR principles. And our consortium consists of research institutes that are involved in data collection and analysis of personal health data, as for instance, our institute, the BIPS, and also of institutes that provide infrastructures that develop data standards and methods, and institutions with a clear focus on community involvement. Moreover, 47 renowned institutions joined our consortium as participants. That means they don't get any funding. And we are also, there are many research data centers, so-called data holding organizations, involved. Now, the data types that we are interested in are population-based studies that are typically heterogeneous, and the data sets are very large and complex. And all the different data holding organizations have their own consent forms. That means there is no standard form currently available for different studies. And they also have set up a local structure for requesting the use of the data. And what is a nightmare in Germany is that the linkage to registry and health insurance data is often necessary, or would be at least desirable, but it is extremely difficult to establish due to German law, because in Germany there is no unique identifier for linking these data currently available. Now, clinical trials are on the one hand better organized than epidemiological study, because you have the mandatory registration, and that means rich metadata are already available, but they often have not implemented any structure for data sharing. The data sets are typically very heterogeneous, and again, the consent forms are not the same used for different trials. And the data infrastructure at the different centers is only built for archiving. Now, what we are trying to set up is the following process for data reuse, and that is just only an overview. We would like to implement a local data hub at each data holding organization. And then the information, the metadata on the data, is then published in the health study hubs that we have set up, such that researchers are able to find relevant data set, and that they are also able to select the variables needed for his or her research project. Then the researcher can write a request for using the data set. In the next step, the Use and Access Committee, as the data holding organization, decides on the request as usual. And the decision of this Use and Access Committee is then communicated via the central access point. And then the bilateral contract negotiation take place also as usual. And then for analyzing the data stay at the data holding organization, and they use a distributed data analysis client that enables now other researchers to analyze the data without physically sharing the data. And now I would like to introduce the central services of the NFDI for Health in a nutshell. And that is the local data hub, the health study hub, the central access point, and the distributed data analysis framework. And I would like to go now through the different services that we have established by using the FAIR principles. That means we start with findability. And for findability, we need two components, the local data hub and the health study hub. Now, the local data hub is based on FAIRDAM-Seq. And it means it showcases an institute's projects and datasets, and it provides complete control for the data holding organization over all information that is displayed, and that is done via the access rights management. Then it also helps the data holding organization to set up a sensitive research data management. That means it enables the management of the sensitive data by linking them, the metadata and the data, in secure data silos. And it interconnects with local data analytics components. Then there is a transfer unit that facilitates the reuse of the data through the management of the access rights. And these metadata and as many as information as possible to be shared is then transferred to the German Central Health Study Hub that is currently implemented, and it is based on Dataverse. And perhaps you know the Dataverse project. It has been developed by the Harvard Institute for Quantitative Social Science. And the local data hub should transfer the protocols, the questionnaires, the data dictionaries, the informed consent template to the German Central Health Study Hub, such that the researchers from outside can see all the information on the study, how the data have been collected, which instruments have been used, and also they know about the data dictionary. And that is very important. That means they are able to assess the quality of the data and the data provenance. And it is also helpful that in case that a new study is planned, they can use the questionnaire that has been used in another study and that might be also of reasonable reuse for the study to be planned or to be conducted. And that helps, of course, to increase the interoperability of the various studies. Now, the German Central Health Study Hub helps to search from variable definitions to study protocols and scientific publication at multiple levels of granularity. It unifies and aggregates multiple data repositories to enable the search across institutional boundaries. But it also helps to publish the data without compromising data protection. It allows for the assignment of a license and a persistent identifier, as for instance, the digital object identifier. It also provides a collection of studies with German contributions with standardized metadata descriptions, and the sources that we used were the clinical trial registers and the epidemiological studies we had to manually collect in Germany. And there's an application programming interface and user interface to deposit, search, and explore the data, including several topic collections. For instance, there's one topic collection on all the studies that have been conducted with respect to COVID-19 in children. This topic collection is called CoverChild. And if you are searching our German Central Health Study Hub, it might look at this print where you can see that one study has been shown. It is in Dortmund Nutritional and Anthropometric Longitudinal Design Study, the so-called DONUT study. And here you can explore the various resources that are available, and you can enter, of course, certain search strings. Now, the study protocols and the metadata are available in machine-readable formats, where we use the Maelstrom classification for the variables classification, as you can see on the right-hand side. And we explore and group studies. We filter and compare the data elements. And you can get detailed data element information. You can perform the data selection tasks. And that is all necessary to then ask for access to the data. That means we are now at A of the FAIR principles, the accessibility via a central access point. And to be honest, here we base our work on the existing portal of the Medical Informatic Initiatives. And the idea is that we have one central access point in Germany for all potential data in the health area. And that our German Health Study Hub is then also connected to this central access point. That means you can apply for multiple data sets with one request already. And that should also be a one-stop shop for the communication and support. That means there should be a unified communication channel between all involved parties. That means data holding organizations and the data requesting parties. That has not been fully established by now, but it will be part of our hopefully second phase of the project. And there will be also a transparency portal. That means you can view and explore the granted data use requests. And that can also be done by study participants, for instance. Now, interoperability. That is a major challenge because the current status is that we have many data holding organizations with study-specific, non-standardized research data. And these need a post-hoc harmonization. And that is a prerequisite for joint investigation of multiple studies. And we have to overcome the methodological flaws that are introduced by heterogeneity in primary studies. And that is necessary to answer complex questions, where individual studies are, for instance, underpowered to examine those. We would also like to increase the diversity of samples and to increase the value of epidemiological research. And what we have done is we think that based on a new project, I hope you can see my cursor here, then based on a new project, the analyst defines the so-called harmonized data schema that includes a list of all required variables and their definition and formats, if possible, based on existing standards. Then, since the variables in the study-specific input data sets will probably differ in variable names, labels, formats, as well as conceptual meaning from the required variables, those metadata are then collected. The analyst can then create a study-specific data dictionary with the respective information. And this is then all put together, and the analyst defines then a harmonization protocol and a rule for each variable to transform them into the desired format in the so-called data processing elements. And these 3 documents are necessary to run the project Harmonize. That is an R project that we have developed, and we provide the data. When I say we, I mean the NFDI for Health. The NFDI for Health provides tailored and tested R scripts for each study. And the executable R project is sent to the studies in a zip file. The data holding organizations only have to insert their original input data set into a predefined folder and execute the respective files. And instruction videos are also provided by the NFDI for Health. And through that project, a harmonization report will be created that includes the information on the transformation, and then the harmonized data set is created, which can then be used for a joint data analysis. That is one possibility for harmonizing the different variables. Of course, you could also do a calibration of the different variables if you know how to calibrate the variables which could be of interest, for instance, for biomarkers that are perhaps created or that have been created in different labs. But there is also the opportunity to use statistical methods for harmonization. One option would be to use distribution-based methods, where you use statistical transformation that aligns the distribution of variables across studies and over time. One example for this is, for instance, to create so-called Z-scores. And that can be done by linear equating. That means you harmonize the variables by converting the values of one variable to have the same mean or standard deviation as another variable. That is easy to compute, but it assumes the variables to be normally distributed, and it does not allow for any nonlinear transformations. If you use the equipercentile equating, then the distributions of variables are aligned based on the percentile ranks with the respective distribution. That could be used even if the distribution of the variables differs significantly in shape. It allows for nonlinear transformation, but it requires a large sample size. The second method is much easier. It is a proportion correct model. However, I think it has a major disadvantage because a lot of information it used is lost, because it only counts how often certain item is positively associated with the variable of interest. And then a multi-item score is calculated by just taking the percentage of the number of positively endorsed items divided by the total number of available items. And that is, in my view, a major disadvantage, that also all endorsed items are weighted equally, and all items are assumed to define the construct in the same way across the various groups that might be of interest, such as the sex group, ethnicity, age, or study group membership. A third method, I think, that is well known to most of us, that is a latent variable model. And here you create a comparable latent factor score across the studies and over time using multiple observed items. And you could use a linear factor analysis, where the observed continuous variables are modeled as linear functions of latent factors, or the item response theory, where you use a nonlinear statistical model, and here only the probability of a given response is estimated based on the respondent's level of the latent trait and the psychometric properties of the items. Or you can use a moderated nonlinear factor analysis that extends the traditional factor analysis by allowing for nonlinear relationships between the observed variables and the latent factors. And now, if you have successfully solved the interoperability problem, and I hope it will get better in the future, then you can reuse the data. And I here would like to introduce the idea of a distributed data analysis framework. The major idea behind is that is to take the analysis to the data, but not the data to the analysis. And there are two algorithms that are used in NFDI for Health. That is DataShield, that allows more general applications, and the Personal Health Train, that is mainly of interest for image data. And here the data holding organizations have the full control over the data set. They decide about the data access, and the data analysis are performed locally without the need to physically centralize or share sensitive data. And only certified algorithms are allowed. And it is there are some research developments still needed. The caveat is that not all types of statistical analyses are possible. And I would like to show you an example in a few minutes. Now it works as follows. You have the DataShield server at the different data holding organizations, and they are in close interaction with the central server, where the analysis request is sent to the data holding organization, to the server, and then the analysis results are sent back. And that can be done with a lot of different DataShield servers. That means with a lot of different data holding organizations. Important is the client server model that is behind. The DataShield servers contain the individual level data behind a firewall. The researcher or the analyst uses the DataShield client to sense code in green, and then the outputs are sent back as only summary statistics via the data holding organization to the central client. Now, we use this idea for the biomarkers for pediatrics collaboration. The goal is here to estimate age and sex-specific percentile curves for biomarkers in children. It requires a large data set from a healthy population, and therefore we want to pool the data for multiple population-based studies. The problem is, again, the ethical and legal restrictions on data sharing. Therefore, we use a federated data analysis. That means we co-analyze the data from different sources without physically sharing the data. And it has been shown by Jones and co-authors that generalized linear model can be applied for this purpose. They deliver analytically identical results. And that can be done via the open source DataShield infrastructure. However, generalized linear models are not the right method for us to be used here. The starting point is the Idefix iFamily Pan-European Multicenter Cohort on Child Health that has been organized and coordinated by our institute. And that has been done mainly by Wolfgang Ahrens and myself. We have been the coordinators. And we defined the metabolic syndrome in children based on the percentile curves for waist circumference, the OMA index, the systolic and the diastolic blood pressure, triglycerides, and cholesterol. And we defined the so-called Idefix metabolic syndrome score, and it allowed us to calculate percentile values for girls and boys. And this definition has been recommended for worldwide use in pediatrics by Chiali and Moon in the Lancet Child and Adolescent Health Journal. The idea is now to enlarge the database and to provide a methodological basis for calculating the percentile curves. Regarding the recruitment status, we received data from 23 countries, and that were 15 studies with 208,000 observations, and we already pooled and integrated those from 15 countries, 9 studies, and 94,000 children. And as you can see from the map, Europe is already well covered. We have white spots, especially in Africa and South America, but further studies are in preparation. Now, what we would like to use is a generalized additive model for location, scale, and shapes that has been suggested by Rigby and Stasinopoulos, which is a standard method to estimate percentile curves. It allows for parametric in blue and non-parametric and random effects in red in the model below. And the response variable can be from a general family of distributions. And all distribution parameters can be modeled. And we would like to derive a federated Rigby and Stasinopoulos algorithm to maximize the penalized likelihood. And what we were able to show is that the federated RS algorithm yields identical results compared to the original algorithm. And the proof is mainly based on the idea that the individual level data are computable using only the information from a single individual. That means it can be computed separately on each server. And the matrix multiplication to estimate the weighted least square and the partially weighted least square estimator in the backfitting algorithm is additive across the servers. Now, I come to an end, and I would like to conclude there is still a long way to go, in particular with respect to interoperability. The privacy concerns are a major challenge in Germany that can be partly solved by a federated data analysis. It could also be solved by generating synthetic data using artificial intelligence methods, as for instance, the variational autoencoder modular Bayesian network, where, however, the synthetic data should be close enough to real-world data to enable a meaningful analysis, but they should also be different enough from real-world data to pose no privacy risks. And in Germany, the privacy concerns, as I already mentioned, impede the record linkage of multiple health data sets, since we have no unique identifier in Germany. And we wrote a white paper and sent it to different politicians. But currently, I think we have a problem that the government is changing in Germany and nothing will happen by the end of the year. Then we have the European infrastructures. It is one is the European Open Science Cloud, and as far as I understood it correctly, that is mainly science-based, and the goal is to break down the barriers to data access to ensure interoperability and promote open science. And the focus is on creating an open interdisciplinary cross-border platform for scientific data access. That should be done via the integration, harmonization, and standardization of data from different sources and disciplines, and the data should come from all disciplines. The stakeholders are the researchers, academic institutions, industry, and policymakers. However, it is not clear how this will be funded after the funding period that runs until 2027. And then the politics decided to start the European Health Data Space, and that should now enable the individuals, that means patients, to control the health data while advancing medical research. And that should be by secure sharing and use of sensitive health data to improve patient care and foster the innovation. And that should also be done by common metadata rules and harmonization of the data. And the health data are from patient records, genomic data, and clinical trials. And the stakeholders are the citizens, the healthcare providers, the researchers, and the industry. And we applied as the NFDI for Health as one potential health data access body in Germany. However, here the criticism is that the funding scheme is still not solved. And let me end with this. There's a strong argument to be made that leaving data unshared is an impediment to the scientists of the future. Thank you very much for your attention.